Hey there students, it's Mrs. Derby taking a quick look at lesson 13. We're not going to do the entire thing, but there are two words that we're going to definitely need as we move forward. In Unit 6, we're going to start seeing that not only can we graph all of these things, but just like we had Unit 5, where we were moving the transformations, we're going to start seeing we can transform trigonometric functions too. So we're going to be transforming trig functions using these two things called amplitude and midline to help us describe some information. All right. So our warm-up is just kind of reminding you that we can take any parabola, like B, and we can stretch it taller by putting a multiplier out in front, a vertical scalar. We can stretch it taller, and then we can slide it to the right 1 unit by subtracting 1 within parentheses with the x. We could take a parabola, stretch it taller, and slide the whole thing down to a -1, just like this guy here, or this guy I guess it would be, D. Or we could take the original parabola and slide it down 1 unit. So using those values that we saw with Unit 5, we just want to bring this back to the forefront. With A, C, H, and K, ones that would do horizontal change. Inside the parentheses, A and K do a vertical change. Same things are holding true here with trig functions, all right? The only difference is now we're going to start seeing that we're going to have things like sine of x minus pi plus 12 or something like that, right? So we still have our sine of our normal theta. Maybe we'll have some other ones that have like 1/2 sine theta plus pi over 4 minus 3. We're going to start seeing all kinds of different changes there. And it comes with these two ideas of amplitude and midline. So let's see how we're going to define those. I'm actually going to skip to the summary, because here they're talking about windmills and how we can change those windmills and what it's going to do. Midline is this line right here. It is the one that is exactly halfway between the uppermost part and the lowermost part. So this is the midline of the graph. So far, and I'm going to use my student packet here, I've drawn on the front cover, on the front page down here, just what cosine, sine, and tangent look like. Because we're going to be making so many comparisons now, I can start to see what these graphs and how they might line up. This graph looks very much like a sine graph. Right? Starts at the origin here, goes up to 1, down to -1, and starts to repeat, returns back to that midline by 2 pi. But what they've done, instead of it just bouncing from 1 to -1, like it would look like that, they've taken that whole graph and they have simply slid it up 1 unit. And so it goes this time up to 2, down to 0. So our midline has moved up 1 unit. So this looks very much like the sine of theta, a sine wave, but it has been slid up 1 unit, so we could write an equation that looks kind of like that. Now we can start to change these graphs, not only just by sliding them up and changing that. So in the lesson, what they do is take this windmill, and at first they start with the center at 0, 0. Right, so they've got this windmill going around at from a point at 0, 0. And instead what they've done is they've slid that windmill. It's a terrible windmill, but it's drawn on the previous page. They've taken that point in the middle that was at 0, 0, and now they've moved it 8 meters off the ground. So now we have an actual stand that it is off the ground. And so that's going to change that wingtip. Over here they were starting with W right here, and if this was 0, right, they were saying, oh, let's just put that midpoint right at 0, 0. Now they've taken that midpoint, that midline, and they've slid it up, so it's 8 feet off the ground. So no matter what, when this blade starts spinning around, it's never going to be at a height of 0 feet off the ground because it's always going to be up a little bit. So it's taking that whole sine graph and sliding it upwards. If we changed it so that the center was 11 meters off the ground, it would take the entire graph and it would move it plus 11. And so we can start to see some things are happening here based on that midline that we have. So the are you ready for more? Here's a different relationship. I can tell because this midline is at 30, that center point of the windmill is 30 feet off the ground. Okay. Not only that, but if we change the length of the blades, which is what they're doing over here in 13.2, if we have a longer blade, we started seeing that we can use the radius and the cosine theta, and radius times sine theta, and we can start to change how long these dimensions are. We're not locked into a single unit for the unit circle. So they start changing these things by making it a length of 3 meters. So we would have 3 cosine theta, and 3 sine theta would be each of our coordinates. And then cutting it to a half meter would of course have that half multiplier. Well, if we're using these as multipliers, we're essentially stretching the graph taller and shorter, because if it's a longer windmill blade, it's going to have a taller height at its highest point, and it'll be closer to the ground at its lowest point, or it would have a larger negative. So here, when I look at this, are you ready for more? Not only is our windmill now 30 feet off the ground, but we're changing the amplitude, and that's the definition right there of amplitude. From the midline to the highest point, or from the midline to the lowest point, is the amplitude. So I see this goes from 30 feet up to what looks like about 40 feet. This has a wing, what do we call them? The blade is, because it starts here and goes up, I see that it has a maximum of what looks like about 10 feet. Okay, so we can picture this windmill spinning around and around. At its tallest point, it is 10 feet above 30. At its lowest point, it's 10 feet below 30. That means its center point is at 30 feet off the ground, and a blade that's 10 feet long. So you see this drawing here in 13, lesson summary. This is our amplitude. Okay, because we're taking that midpoint and looking at how long it is, we can also look at the total height of a graph and cut it in half. Alright, so we can do amplitude. It's either the distance from the midline to the maximum, and remember this is going to be like a relative maximum, because there's going to be a lot of them, because it's periodic, it keeps on repeating. So it's that distance from the midline to the maximum. Or we can also think of it as half of the total height of the graph. Alright, so a higher amplitude is going to have a taller stretch. Really, when we're thinking about these, some good things to know is that a midline is going to change our vertical translation. Right, this is going to turn into our K value. And the amplitude is vertical stretch or shrink. And when we see that, we're going to be looking at an A value. So A for amplitude might be a new way to start making that connection. That's our summary from lesson 13.